I'm not happy about my audio. Come on. Stop it. Could have fixed. Yeah. Hopefully that will be better. We'll find out. So, okay. Oh. So we have the static class. We have the multiple windows, and the initialize. Static classes indeed can have initializers, automatic initializers. So that might be something that I get, right? Okay. Yeah, I can do all that. I could figure out some way of making this look nicer. For one, I can get the theming to match my i3 setup. Oh, did I not, oh no, I did. So, we got the initialized. Kind of abstract and hide away some things. Yeah, we need update render with line. That doesn't need to be a thing. Oh, wait. Yeah, or, right. Like, I know that a lot of new programmers are used to a lot of beginner programmers are used to dealing with functions as like properties, basically, because a lot of properties are kind of a new concept. Not very well known. I should probably explain for the YouTube what we're doing. So this is a game engine that I'm working on in the D language, and I am trying to, I'm basically going over it and looking at things that I like, things I don't like, scrapping the whole thing and starting over. Right, this is after 1 month of work, and I think I could do a lot. Not only do I think I can do a lot more, a lot better, but I think I could do, I feel like I can make it a lot more coherent. I can do, and I feel like I could get a lot farther than I have in the last month. By starting over, I'm pretty much gonna end up rewriting everything anyway. Right, I'm not happy with how AMP has been handling my code base. So basically relegating AMP to something only for like dealing with like Git or something like that, right? So yeah. Oh. Okay. Okay. So we can do quite a lot of things here. Good. There's a bunch of things that I want to take care of, but it's fine. So let's see here. Okay. So we have there's a class. We have multiple windows. I should update well, these are do you want, window.update.trigger now. Alright, do we want that, or do we want window dot do we want something like that? Window.render.trigger.now. Alright. I think that's something that, because I don't know if or do you even want that, right? Hmm. Okay. So a lot of this boilerplate stuff. Okay. So supporting multiple windows. I should be able to make future proof. Right? Something as simple as, hey, I have a thing. I want things to be as decoupled as possible, so that if I make any changes, it doesn't really affect it. Right? I don't have to go through and refactor my stuff in 10 million places. So it's not very nice, right? Okay. So we like the static classes. We like the multiple windows. We like what else do we like? Does beeline help? Are you gonna be an asshole? Okay. Leon has these tricky, statistics. Let's see, the designer that and covering an object stored. Garbage collected by defaults of destructors parts called deterministic like in C++. Predictable cleanup using this scope here. What kind of scope? Is it? the static construct can static these because it'd be really nice if we could just fully control it. All that module termination. Gotcha. Okay. She does. That does. Yeah, do things quite nicely. Because we won't put down and sort up the static. Yeah. Okay. Down the destructor. Are you kidding me? Yeah. Property. Right. We got that. We'll do that and then let's take a look. We have the mouse position, we have the action, we have bending contact. execute action. Actually, we have right, left, and read because all this is going to be on a separate and then separate yeah, that. So okay. Central it handles it just manages it. The app should be that manages the other components. So input we have the core idea is that we have an input thread, which is fundamentally operating on a separate it is operating on a separate thread. Right? So we have kind of two. His input should be, because we don't want to see, the mouse is a high frequency input device, right? It's a continuous input device, so we don't want to have the same thing with joysticks and stuff like that, right? They are stateful. As with buttons, buttons and keys are stateless. They are evocation. They're event. Like they're interrupted. They operate. Like the idea that I want is that if it's like an on-off, I want to have effectively a rising edge detector and a falling edge detector. Right. That's basically what I want. So how does this work? Because we want a timestamp of. Well, I mean, and all this is going to have to be in an internal centralized sequencer. So I mean, it would be one of these things where you only lock it for the right buffer. Alright. Condition for condition. Yeah, something like that. Because I actually don't see we have like an int name, right? So is that something? Because like a lot of this stuff is, I'm not entirely sure, like I know what it's supposed to be like because I told it to do what I thought it was doing, but a lot of this is black magic and I don't get it. Because where's the delegate? Where's the okay, class input. Static action until findings organized by context. Having multiple contacts is really good. Because being able to have like a mouse, position and stuff like that. And I will also refactor it so that the mouse position returns a vector and all that shit when we get there. It just needs to work at first, right? So I just look through the module by default. A little bit away from this. Got it. Public. Okay, so you can do public. So you can have scope management quite nicely with all of that. It's good. I think this is what I'm going to start using AMP for, is just looking at documentation. For a number of reasons. One, it's able to simplify things, it's able to give, and a lot of this stuff is quite accurate. But I might look into other autocomplete systems for any of them. AMP just cannot do that. Because like the biggest thing that Copilot is really good for is predictive text, right? Is predictive coding. It's really good at that, and it's super nice to have that. But I don't feel like paying a bunch of freaking money that I don't have. And I also don't like the fact that it completely overwrote my IntelliSense. I don't like how it's all like, oh, you have an error here, fix it with Copilot, when IntelliSense worked just fine not even a year ago. So yeah, there's a lot of things I'm really displeased with Visual Studio and VS Code. There's just a lot of stuff with that I just do not like. So okay, so it's module level. Because I do want like these modules to be like swap in, swap out, stuff like that, right? I think the things in the way that it is in D-Lang is a little bit crazy, because in C++ you can have as many or as few files as you want, right? In Java, every class has its own file. You get these very crazy structures, right? You get very many very small files, whereas in C++ you tend to have few just monolithic files. Let's see. So there needs to be because the mouse moving around and stuff, if you need that every frame, then there's ways of capturing that everything. Right. And I'm not sure that very many games will need to have like like there's just so many reasons why you don't really need all this, right? The only problem is that things like the mouse buttons, you might need to have more strict bindings. Like as an event. Right. So, okay. If having a logger class, I mean, I could have anti-risk. I don't need to have. I literally just need it to work. Right? It doesn't need to, because like I really like having a logger for a file, for the console, and for both. Right? Right. Yeah. I mean, I like doing a lot of other stuff, but having a jump cable and all that stuff is fine. Having an array of function pointers is basically the same. So I guess the logger is fine. Yeah, so what is it that we have in here, right? We have the... Yeah. Right. Okay. Yeah, because here we have... Oh, we can't. We can't do that because of the try-catch. Right. Because the int main, is in there. No, it's fine. I have to, okay, yeah, what we want is, largely hidden, just works, right? You shouldn't have to, right, we want the app.d to be a black box, right? A black box voodoo magic, right? Where you just handle, you just throw stuff at it in your main function, when you're building your application, right? So you want there to be, you know, alright, you want there to be, you want there to be, you know, like your ints, alright, you want your, you want the Windows, new window, right? Dot with a, you know, 800 dot height 600 dot title is, you know, hello window, right? You want that, right? Right. This is the initial state, right? You could do a create, a window create. Or an app.spawn window. Alright. Could do that. Do we want that, or do we want, or do we want the, right. App.spawn. New window. And then here we have width 800, height 600, title hello window. Yep. You do that. Which one of these do we like more, right? I think yeah, that's like this will set everything up, right? This will set everything up before it even enters the call, and then the call will handle it. I mean, it literally just reroutes it, but because the syntax is different, because the way we interface with this is a little different, because we could also make it so that that you have to go through the app, right? Or largely go through the app, through app, right? Because it would be nice to have like a big old like right, you have try. I've got spawn window. I don't know. It will be interesting, right? We might be able to do something. Because I mean, we could make it. I mean, we could templatize it. Alright. Because we can make it. Because we can make it, you know, spawn window, right? New window. I've had things like that, right? Being able to define how we want to interface with things is very useful. Right. Okay, so we could do here we could do the int so we want to try well, I mean here we just do row. We just do that, right? Is that it? Or something like that, right? Yeah, can we just try catch throw? Wherever it is. Alright, that's like how you're supposed to do it. not exactly how it's managed. Because then we could also put it into the console, log it to a file, all that other stuff. You could say handle section internal tools. Right. We could do try, because then here we want to say app create window, new window dot width 800 dot height 600 dot title hello window. We could do that. Because we're going to be updating this stuff. So what we want to do is we want to set the we want to like set the chain in a certain way. I have to figure it out. Right. Because like the app initialize and app shutdown. The static constructors, they run on module load before main executes. Meaning that, okay. There are any errors, then you have to catch them internally. Outside of the entry points. Inspect this one before main. So you need to put them inside this structure itself. Main's so if we have something like this, right, we don't necessarily want to have it like catch, which means we don't. All right. Right. Or okay, so let's rewrite this, right? Because we can have something just at here. Amp dot create window new window. Dot width 800. Dot height 600. Right. Dot title hello window. Right. We have this. So the main isn't going to be handling this. It's just going to say, hey, do the thing. And then you could say something along the lines of, app.run. Right? You might have not have a show or anything. Having overzealous flexibility early on can be a bit of a pain, but it's also not necessarily the worst thing. If you have too much flexibility too early, then you just start overzealously abstracting things away. And the more abstractions you have, the harder it is to trace back, and the harder it is to boil everything down. Right? If you watch senior developers work on a project from start to finish, you will see them have these monolithic entry points, right? These monolithic main functions. And then, what they do is they do the most caveman, smooth brain, brute force solution to the problem. They go, okay, it works. And then they take a look at it and like, okay, how can I make this more real? Right? You go through the brain first, and then you start giving yourself wrinkles. Right? That's how senior developers operate. Right? Am I particularly doing it that way? Not really. I should. Right? But I have a tendency to get excited about things, That's why stuff like utils and things like that are very handy. But it also depends on the kind of problem that you're doing, right? Because there does require at least some level of forward thinking. Otherwise you get, Goku running the entirety of Guilty Gear. Right? So it's just kind of like one of those things where you have to worry about these things, right? So I also just really hope that my audio has been fine this entire time. Hopefully it is. Hopefully it has been. If not, then oh well, I guess. But yeah. Alright, so we have the yeah. So okay. So we could have that. We could have app.run, right? And then we could have something along the lines of what, like app dot run equals handle your loops here. Right? It could be that. App.run, and then you can do that. Well, I mean, no. So you could have something along these lines, right? So, do that. We'd want something along these lines. Right. We have app.create window, new title, all this stuff, right? Means that the so problems in the app thing here is that we have we'll need to manage errors here. We'll need to manage destruction errors here, right? Yeah, largely hidden just works. A central class that manages other components. Largely hidden just works. You know, we want it to. We don't want to be exposed too terribly much, right? Having, you know, these sequence of events or things like that. Having like the run sequence be like a thing. I'm not entirely sure how I want to do that. Like I could just start it off with like, say, hey, here's the here's like the like the event chain, and then map it to like the event chain, and then map it to like set frequency to some number of perks. We could do and handle new loops here, or do we want to do something along the lines of, you know, or do we want to say that, you know, app dot of event chain is equal to right. We could do something along the lines of, say, swap or swap input physics draw. Right. Is equal to this, right? Right. And then you can say app dot frequency is equal to 60. Right. Or chain time, right? I think easiest would be like a chain time. App dot chain time will be equal to time utils or yeah, and it'd just be time utils. I mean, it could be time utils dot time time seconds, right? Time seconds, 116 right. For 60 FPS, right? Or it could be from frequency or time from frequency. Time utils, time from frequency, e seconds from frequency, or u seconds from hertz, right? And then we could do 60. Right. Microseconds from hertz, right? So now sub-millisecond wait times and wake up times. Like, I don't I think people underestimate just how quick a millisecond actually is. It gets really okay. So we have this, right? So we can do the event chain. We can start with swap. Input physics draw. Alright, input physics draw wait, right? What does this actually do for us? This allows us to, I think having these things be in this way is probably how the API, like how I want people to interact with the API, right? So you have the event chain, and you do all this stuff, right? Because I want I want all this to be, I prefer not to even just have a run, but I think having an explicit run, a call to run is fine. Twitch, you've been very quiet today. Although I'm not surprised, it's New Year's. Happy New Year's, everyone. I hope your 2026 is pleasant. Okay. So, I got that run. Okay, so I think that's how we want the app. Alright, like I want this to be largely what the API should be, right? This is how I want it. So, maybe have a weight or whatever, or like the weight can be just implied. Swap, swap input physics. You swap first. Because that's basically like you would think that it's all like on a different frame, but if you because you can essentially treat swap as an instantaneous input, right? So you can do that. And then there's also like app input, app swap. Right. We could do app.swap. We can do app.input, app.physics. Alright, these are provided, app.draw, right? Because then you could also do your own user, your own user. This is probably going to be the most idiomatic way of doing it. The most idiomatic how do I explain? Like most, not necessarily the most idiomatic, but just like the most like normal way of doing it. The most intended way of doing it. There are ways of having multiple physics calls, multiple input calls, or whatever like that, right? Like there's different ways of handling it, right? Because I think having a poll inputs here, you swap, you poll inputs, you handle physics, and then you draw, right? So, and these are all events and things like that. So there's that. And it's because there's, each thing might have a different physics updates or whatever. And this is where like entity component systems come in, or nominal token pattern. because like the way that the nominal token pattern works, or how an empty clone system works, is that you have one, it literally is SIMD, right? You have one, instruction, one sequence of events that operates on a bunch of different data that's all very similar. So when running it, you could either dispatch it onto a GPU, which, having GPU, like hardware accelerated physics calls, is very nice. It's very, very nice. It's very useful. It's very demure. Very, whatever you want to call it. What the hell is even demure anyway? What does demure mean anyway? Odd question. What does demure mean? Like I have an idea in my head, or like internally. Oh, gotcha. Demure. Yeah, that's pretty much what I thought it was. Close to it. The the point vector in my biological neural network was in the same realm as those other meanings. So. Alright, so we have the event chain. I think something like this. Right, because above the main function is where you put all your crap, right? Or you just import it from other modules, right? That's pretty much how you would handle it. You could do, because then you could just subscribe to the physics call. You can just subscribe to the provided physics if you want provided physics. You pull the input. This would probably be pull input. App that pull input. App that physics. App that draw. And then you just wait until microseconds from hertz. Time kills, microseconds from hertz. At run. Which will handle all the window creation and see if that works. So come on, events. Yeah, pull input physics. So, we have these things. We have the sketch pad, and this sketch pad is going to be quite big. I'm going to be using this for other stuff, right? So, what happens if you? Oh no. Interesting. Oh, I could switch between the two. So I could do that, or I could do flip. Interesting. Cool. Cool. That's good to know. That's really nice. I can do a lot of really cool stuff. I can't really do. I mean, I just pretty much rely on steady body. It doesn't. It'd be nice if I had more people in here. I'd have more mods. Give mod privileges to a lot more people. It would be nice. Yeah. So we have, I think that's the kind of the overarching ideology that I'm gonna have, right? Having this kind of thing, I think is something that I'm cover. Right? Because I feel like frustrating. I don't know exactly what's going on here. Alright. So, I think I'm back. And, yeah, it's currently saying it's unstable, but, OBS seems stable. Restream IO seems stable. And OBS is doing really good right now, isn't it? Yeah, it's doing some stuff in it. Still need to figure out what the hell is going on with that. Okay. I don't know. We have app. We have the int main, how the int main APIs work. So, or how the I can't think. Anyway, sketchpad. And here we have app API example. Right. Okay. So here we have the main. So we want that. This shit is fucking dumb. So let's take a look at utils. Utils is going to be largely untouched, right? Like utils is basically perfect. Yeah, because we have the op call. Handling like operator overloading. I really don't like that. I don't like that syntax of how that works. Just because of how all that shit fucking works. It's really frustrating to me. Because I feel like you could just quite literally just yoink this entire fucking. This file is fine. For the most part. Alright. We might end up rebuilding it from scratch. And largely just take on the experience that we have. Right. Split next to something. Like how it was, split next is really good. IEEE 754, Level Precision Pop. Simply because it is what it is, right? And these are very easy. So Yes, you could. Yeah, you can. I mean, there's just no reinterpret task, right? Um, yeah, there's just no reinterpret task. There's just ways of like there's. It would be really nice to have a reinterpret task, right? Reinterpret. Alright, because what you could do is you could just you set a temp variable to find it. And we have the utils. The utils is largely alright. And where the fuck did the events go? Can you not take a look at what happened to my event? Oh. No. Fuck. Or did I... I need you to take a look. It's in a book at my Git history. Weird. Trash event.p. Oh, okay. I did not delete it. I just moved it. Okay. That's fine. There we go. Let's take a look at this nightmare. The events. The fucking event system. This is gonna be such a colossal pain in the ass. But it's gonna be worth it. Having the event be having events be managed in a way that you can just say, hey, I want to, you know, being able to so cleanly be able, like, you basically what you want to do is you want to just you want to must be called after execute. Also, test your code. Test your code. Test your damn code. Very important. Write unit tests. Or have AI write unit tests. Right? AI is actually really good at writing unit tests. Perez. Because it's very good at writing. It's really good at using your code. It's really bad at writing. Right? Because you can just be all like, I want it to look like this. You know, I want this to be the general API use case, right? Like that, so that we can see if there's any, right? And things like that. Because then we can do summary MD. That's fucking Garbo. Let's take a look at here. Task scheduler. We want the scheduler. We want the trigger. We want the because the trigger, it's you can, instead of this, you can do like a class. Because I don't really know if I want to, because I want the payload to be stateful. Okay. Because we want to be able to defer that information. So defining a class within the class, defining a subclass, and then having, like, can I do, because I want to have like a static instance of a thing, of a struct that's, you know, valued, because it needs to be a struct that is valued, right? But it's okay. I feel like I'm thinking too hard. Alright. I think I'm thinking too hard. Here's the Alright, because event.d needs to be fucking thing. Yeah, we can get that going again. So I have my references and shit like that. Right? Because like another thing is like, hey, how is this, working, right? Like, how did I have the API for here? How did I have the API for this, right? So I don't have to go and search and look for shit. And then I can have a completely different AI do like the nifty autocomplete shit. Because there's a few that can do that. I just have to do a little bit of research to find out what would be good. Because I can have AMP do wide breadth stuff like the whole GLFW setup shit. I could just have it do that because I don't give a shit. Rewriting the timing kills. We can just have AMP do that because it's not, a lot of those systems are very self-contained, and AMP is very good at small self-contained units. Unit tests have AMP do that. Right? I can just have my fucking intern take care of that shit. I don't want to. Writing documentation, have AMP do that. I don't want to. Right? Things along those lines. So I could have the different. I don't know. I'm still kind of working like how do I use AI in my workflow efficiently, because I feel like while it's here before the bubble pops, I might as well use it. Right? Might as well write it while it's running. AI will never fully. There's no way that AI will ever be good enough to. There is no way that AI will replace people in. That's not a thing that will. It's just not. It isn't. It just isn't. So we have the app API example. We want to have we can do events AP example. Right, because then you could do desired API usage. Right, we declare a class, we declare a listener. Alright, some event, some listener. And then you just handle the event in here, time until time answer. Because like the name isn't the payload needs to be something a little bit different. 'Cause I don't like this shit. Right? I don't like having this. Right? I don't like having this be in a function. I don't like that. It should be be something very, very different. Alright. It'd be nice if it was like implicit typing or trigger high event. Trigger could be high event dot trigger could be trigger not event. Yeah, let's do, let's say, static class my events struct. You need to define the payload. It needs to be called payload. Because then this could be, you know, double time, int window ID, fucking string. Because you want to be able to defer that it is an instance, and you want it to be the issue is that there's just there's just so much going on here, you know? There's just so much. I don't know. There's just a lot to occur here. Okay, so we have the event. So what happens if we don't do through that? That's cool. Can do that. What do you mean by okay? There we go. So it does work. Cool. Just takes a little bit. That's good. That's really good. It's awesome. Because then I can have like I can text stuff, like I can send stuff out through the various means and stuff. So we want the event to do that. We want a static payload. Because like this can get so confusing. Right. This makes things very, very rough. Because you are defining a payload within the event that you create, yada yada yada. Because also like the right. Because you have a static instance of the payload, you have, you know, there's a lot of yeah, because you can have a class listener or class my listener. Right? Because we have the listener, we have this, and then we can just append shit to it. Because whenever a listener is spawned, it should automatically start listening. Right? Yeah. Or wherever it is that you want to handle. Just whenever you add it, you set the handler, right? And the handler can be defined however the hell you want, right? Like it doesn't really fucking matter. It's not like this is the idiomatic way, this is the intended way, but you could really do a lot with it, right? Just because like later on there's gonna be so many different things that are gonna be doing stuff, right? So like these are things, right? And this is like a non-component. This is non-component. Which also means things like, well, what about because you can also have like behaviors set into the listener and have a listening behavior, which wouldn't necessarily be a terrible idea. You could have, you know, a physics behavior that, well, it would be one type of physics behavior that just listens to the physics thing. You could also add handlers to it or whatever the hell it is, right? There's a lot of different ways of handling it. The behavior pattern is like the behavior component pattern is nice because then you can have a lot of shared behavior across multiple different types of things. Like you could have a shopkeep behavior, right? And that handles things like because like you want to be able to reuse. So having a shopkeep behavior or something along those lines, or being able to abstract some of that stuff away so that you can have, hey, I want to make into, like you could have a function that's like make shopkeep, and it'll just populate it with, make into shopkeep, or just you could have like a bunch of factory functions, free floating factory functions that you just pass in a token object, just anything that is a token, and it'll just populate it with the stuff. You can have like shopkeep. You just pass in a token, it just adds, it adds its stuff to it. Right. And then it could, also potentially like update, certain things like for the destructor. So I don't know. There's just a lot of things to keep in mind with it, because like I had it absolutely nailed down with like scoping and stuff like that with C++. Made automatic clamp very nice. I'm sure I'm gonna have to do a lot of stuff with that different, but it is what it is, right? So alright, because I don't know. I'm kind of looking at this and seeing how it is, just kind of refresh how it was done, see what things I like. Let's take a look at the Post-Mortem. So we have that. So we have payload, I don't know. Yeah. This is really cool. What is this? Retrowave 80s Vaporwave. Plastic Paradise. It's really nice. How long is this? 3 minutes? Very nice. I like it. It's chill. There's like synthwave and stuff in here. Like this is a huge playlist from White Bad Audio. I literally just downloaded the entire bloody thing. I could have done it the proper way or not, but I also like pissing off YouTube. Because Google can suck dick. Monopolies are bad. Stop it. Get some help. But either way, let's see. Right. We don't need an inheritance chain. We don't want inheritance chain. We would prefer compile time type safety. Self-referential handlers. Yeah, all listeners set up in one place. Basically, you just want to, whenever you're setting up a listener, you can just append everything, just right then and there. Having it, do that is very nice. Having the event trigger. I just feel like this is super dangerous. Okay, in this file, I've had more people in my chat than I wouldn't need, I wouldn't need to talk to AI, but I also don't have time to be begging people to come watch my fucking stream. I'm not doing that. It's not something I'm gonna do. Would like to compare this to the possibility of having events, event child classes declare a struct within themselves and hold a static instance of said struct. Be changed when a trigger is called. I only care about these two things in isolation for now, ignoring actual implementation, just the pattern of setting payload with a stored function lambda versus struct. Right. This is really all that I care about. This Well, I mean, it would be I'd be passing in a new, well, I'd be passing in a struct. It'd be well, correction. It would be my events dot trigger dot payload like counter plus plus or something similar. Well, basically passing in a function versus passing in an instance of struct. Yeah. Yeah, okay. Describing what to do. Declare. If the data difference on compute mutate inside the trigger, while start approach flag passes a prepared state correct. Lambda is more flexible procedural. Got rolling. Okay. So because like what benefit do you have with lambda patterns, right? The lambda pattern gives you access to counter value. Can you not do like the event counter request? Ooh. Oh fuck. You can't necessarily do, because this is that. Oh shit. Okay. So the big difference here, right, the big difference here is that we can have having my event.payload my event.payload my event trigger my event.payload. So this becomes a question of flexibility and other things like that, because you could do, because with that trigger, you can say, hey, but the whole point is that my event.time is not when the trigger was okay. Doing it at .now obfuscates the it obfuscates the information, because there is a very subtle but semantic difference here. The struct pattern will mean that it needs to be doing things within the reference frame. Okay. So, using struct versus function is the semantic differences of that a struct that passes data within the frame of reference. The frame of reference at schedule at time of production, whereas the function sets data within the frame of reference at time of consumption. I mean, I wasn't triggered down. A little bit of a semantic difference on the API is that it's not exactly how that works. It's an event scheduler. But because if you do an at time, So this gives the possibility of things getting very messy. So this isn't as safe. API for scheduling event calls. As in, you can refer events at a future time. So the semantics here is that the function can use the future time of actual triggering as reference, whereas the struct can only see current time of schedule. Rather than execution. Alright. So the difference is also safety. A function is very fragile. It's not necessarily fragile, it's just very widely scoped. The world is changed by execution. Fire around us is the actual current state, and it runs not what was true 5 seconds ago when it was scheduled. More powerful for scheduling APIs, it lets handle exactly real world conditions at the moment of execution, whereas the struct left into the state that uses stated when to schedule. Means, but the struct is more. I don't think there's really much of a way to do a hybrid, right? So it would use elsewhere rather than should be, as in what should be handled. Suggestions? Because like one way of doing it is you could have the event trigger. My event. Oh wait, but it's not. It's not an instance. Unless it's a static instance. That's not really a thing that it can exist. Because I just want a static class. I don't want necessarily a singleton. I don't like singletons. Singletons are not great. Even though I'm using this, even though like the structure would use a singleton, right? Could be a singleton pattern. Yeah. Constrain arms visibility instead of casting a bear over belly. Make a mutual reference to only. Will still have vision of all events anyway. And variables. Now would be effectively to truly restrain vision. Right. Yeah, because the only compile time isolation that I have is pessimist. Which is kind of what we want anyway. Oh, did I just use that? I think. I worked it. Okay. ESL. Restricted expression path. So I can either have raw lambdas, right? Right. So I can either have raw lambdas, which isn't really something that I would like to do. Right. Okay. So I can either have the safety of destruct only and accept the time scoping issues, which is not looking good, which is admittedly not looking good. I can pass in payload to be modified in order to limit user error. User error and mistakes at the cost of having singletons and other extra abstractions that not necessarily be needed. Yeah, but like, I don't know if I like that, right? Like, I don't know if I want to have because I don't know if I want that to be a thing. Because I want to have good timeline scoping. Because I want the scope of the timeline to be specific. And I would really want to avoid custom macro data. Really think the custom macro is way out. I just don't like the unsafe nature. Alright. Okay. Yeah, because I don't like this. I don't like the singleton. It makes it very declarative instead of imperative. Alright, it would just be better if it was just, static. Yeah, double. Static. And window ID static. And because then you can have a listener do that, and then you can have the rough approach is probably your best practical move, right? Deferred execution requires lambdas to capture the first state. Lambdas can't keep the return. Then hunting globals stays lightweight. No singletons or but it is required. Issue is that it requires singletons and extra abstractions. Because one needs to declare a struct within each. Yeah, you need to declare a struct within each event type, and these can be misnamed, and you need and then you need a static instance within each of the events. Yeah, that's, I don't know, I don't like that. Right, I think eating that is not enough boilerplate plus developer discipline. No boilerplate. Don't be dumb. Yeah, risk of misnamed, inconsistent structs. Yeah, you have. Still requires declaring a struct in each event type, maintaining a struct instance in each event. If you're actually reducing, you haven't actually reduced it. You've just shifted the safety constraints from don't touch globals to remember to declare the struct correctly. Yeah, you have. If you're already relying on developer discipline, then you might as well just remove the damn boilerplate. Simplicity, right? So we want simplicity. We want something else, right? So we want there to be something. So within here, we have the event, my events dot add. We have right. Well, we have the handle event here. We have This also means that, you know, event.addThis. Being able to maintain and operate, maintain, mediate, and moderate these are, you know, like things that I would want to handle, right? Okay. So alright. Yeah. I think control shift something. Yeah, I want to do. Okay. Yeah. So we have that. And then we have you know, in some block here, right? We have, you know, trigger my events. Okay. Trigger my event. My event dot time equals, you know, time utils microseconds dot now. Right. You know, or you could have like a counter, you know, a counter. You can have, you know, my event counter plus, you know, and then front line my event or see, this is why I don't equals some text here. I mean, it doesn't matter, but right, and then we can say schedule in at t at time equals. Right. I mean, because you could say at t equals, right? time. Yeah, or some, you could do, what is it, like duration, exclamation point, some shit, right? Time, time, you bills, that time, E seconds, seconds, S, 5, right? Seconds, S, 5. Let me chose that time, seconds. Right, that time at E equals 5 seconds. Or in trigger delay of do like trigger my event time, or we could do trigger other event dot thing foo equals bar, right? Dot delay of dot delay equals time equals time microseconds or milliseconds. There's 7. My event, other event, that event. That I think it's something like that. Oh wait, no, it is, okay. My bad. What's that? Because we're specifically calling the, yeah. Fizz equals as dots now trigger that event now. All these are because you could do there's a little bit of syntactical magic going on, but I think it's at the ego, because this kind of syntax kind of states that you are setting something. Right? This makes it very clear that you are setting something up. And I think that's something that would be good. So. You would have some function. Right. So you'd have some function have these things. Right. As an example, you'd have these things. Because you would want there to be, because you want there to be some nice, kind of situations here where you have these things doing things that you want to do. So, okay. Cursor, a block of example code. I wanna see what you think of it. This is an example of use, not implementation. So that was API shape trigger, mod event is coming event trigger, and the fluent chain of is included. The bare lambda approach is honest here, no pretense of constraint scope. The design still requires each mod event needs members. It's unavoidable if you want compile. Trade-off is you get real-time data at execution time. That developer must remember to declare the data. No strict hiding it. Just raw data. Well, I feel that when the developer is creating the events, they would need to define what data that event expects regardless of API shape. The real usage here is that we have a plain and collated API shape that intrinsically guides the developer to good practice while maintaining flexibility and not insulting the developers' intelligence. If dev messes things up, that is on them. I'm not hand-holding. Providing opportunities. Right? This is much more about providing opportunities than it is about holding a developer's hand. Video games are complex, and if you have whenever you have a general purpose game engine, you're going to have some friction somewhere, because that's just how it is, right? That's why game engines like RPG Maker are so rigid, right? You just kind of, it makes it very easy, very approachable to make it, because all that you really do is just make the map, you make the characters, you just kind of accept whatever damage rolls, damage calculations the engine provides, and you just kind of eat it, right? And you just go from there, because you're less worried about the nuts and bolts and more worried about driving the car, right? And that's kind of a big difference here. And my engine, I am like just saying, hey, you have, like, here's the parts for the vehicle, build the vehicle, right? Which means it's more work, yes. But you have a lot more control, and I like providing. Right? So does guide good practice, make it clear what event you're triggering. The lambda parameter position shows you're setting this event state. Are explicit about timing, right? Have full flexibility if they need it. You're not trying to be a nanny, you're being clear about intent and trusting the developer not to shoot themselves in the foot. The boilerplate declaring static members in the event is minimal and necessary regardless, everything else goes that is a very good assessment of this kind of API. This is an API shape that I would like to move towards with all this. Right? Yeah, because we have the event API, we have within some function, we have that, we have the listener, we have the trigger. And the trigger could be either a templated class, or it could be like a templated struct with a callable something or another. Or it could have a constructor, and it can return, a trigger. And then like add key. These are all things that can be. So like these are, and I am going to be writing a lot of it because I want to handle a lot of things, right? So this is a declaration of intent, right? These are this is a declaration of intent. Let's just get rid of that for now, because I want to declare intent here. Because like there were some things that I really liked. For instance, if I go into trash and I take a look at event, well actually, no, I want to go into here. Okay. Okay. So, we want the... So, there were a few things in here that I liked, right? Having the... Yeah, so we want under... right? We want to have, say, hey, here's an event handler. Here's an event handler. Right. Right. Because it needs to, there's no way to just kind of free float it, right? Because you can't necessarily say, this and things like that. It's not really something you can do without the physics. Well, I mean, the physics could there's a lot of reasons why it's not so good, right? Because we want, right, the add this equals some shit. But we don't necessarily want to do that, right? If you have a listener, then you might have, like, I want there to be because if you were creating a class, you want to add you want to handle because I should be able to do the entirety of the event system in a month, right, by the end of this month. Like, I'm tempted to take a look at color dates, which is color dates. Okay, so here, in the constructor, we want the constructor to add it, right? But it's kind of I I want to add an instance of it, or like I don't want to add like a whole new delegate every single damn time. Like that's rough, right? That is super rough. That's really bad. Because you're basically creating, spawning a fat stack of just free functions. They're all very, you know, yeah, like I feel like that's gonna eat up memory super fast. It defeats the entire purpose of having um these kinds of systems, right? So mm, no. Okay, so we don't necessarily. What we actually want is we could do add this comma and then hit target. This is got to add this comma delegate. If we make it a void function, right, instead of returning a reference, because you need to have because effectively it's a mini game, right? You have the relationship that every single ball is going to have this particular handle. Which in essence this means that you are having the class ball is having, you know, the ball class, like anything that is a ball. Because it is just going over. I'm gonna have to think about how it's set up, because if I have every single entry having its own delegate, that's like super fun. Right? One way of handling it though is that you could have like because I don't know. Because I want it to be magic memory management, right? I want there to just be some hidden black box voodoo magic going on in the background. Dealing with this should be very declarative, right? Dealing with this should be very imperative, right? Okay. Because we have a problem here, right? Implementation. The other way of doing it is that you have an unordered step. But I don't know if that would work. Because I don't want there to be... I don't want... I do not know what to do here. Because I don't like how this is a new... I don't like how this creates a bunch of because technically speaking, what it should be a reference to a delegate. And that's stored in a set. Right? but I don't know how to. Right. The triggering is fine. Right. The trigger function is fine. Right. Because we could also templatize the because we can templatize the this stuff, right? The operator overload, we can templatize it. Or you can templatize the constructor or some such something. There might be some other ways of handling it too. We might do, you know, a my event dot trigger, right? Because the order doesn't really matter. Just semantically, speaking in English, in plain English, right? You want to say, hey, trigger my event with this payload at t equals some time, or trigger this event with delay of, right? Or trigger that event now. Trigger other event, delay, blah. You know, with delay. You know, at time equals. You know, other you know, semantic bullcrap, right? These things are pretty easy to handle. So that is fine. This shit though. This shit right here. Right. Because you also want to say, you know, yeah, my listener self. Oh, this is the trigger. This is not. Yeah, here we go. Yeah, because it's self draw mesh. Render model. Self dot model. Or some. Yeah, or some shit. Yeah. Okay, so we have. Right. Okay. Here. This is a free delegate. Alright, this is just a raw delegate. Also, handling things just purely conceptually, I think, is something that I would like to do. That's just something, I don't know. Okay. So, alright, amp. An example. The registering events and handlers. I like that the handler is cleared within the scope and point of listener registration. What I don't like is that it suggests that the event stores multiple delegates for each type of listener. Stores multiple delegates for each type of listener. Not sure if there's a simple way to resolve this, as I would like for the event to store one delegate for each type and simply pass in the context for the handler to manage. Correct. Yeah, I want event 1 delegate per listener type. Well, a correction. I want the event to store one delegate per listener type. Yeah. Class panel listener. Yeah. For listener type shared by all instances of that type. 1 delegate per listener type shared by all instances of that type. Yes. So when firing, we call ball delegate once, or loop ball instances through it. Yeah. And the paddle delegate separate. That requires the event to key delegates into type info or use templates instead of keying by listener instance. More complex internally, it's meant to pre-cleaning. The event knows, here's how to handle a ball. Here's how to handle a paddle. Correct. It be trivial to pass in like the static handler reference, but I don't like that flow. It leads to chasing declarations. It leads to chasing declarations. Right? I want to cut down on chasing declarations. Right? If you want to change one thing, you should only have to change it in one location. Right? If you need to change one thing, it should be in one place. Right? Correct. Right? Because like one way of doing it is that you could say, because instead of this, you could say something along the lines of, say, hey, or listen to my listen of type my event, listen at my events, and then handle here, right? You do that. You could say listen my event, handle here. You can say listen to my event. And that can be declared in, you know, well, it might be easier because then because whenever you call listen to my event, you pass in an instance of itself, right? Because you have access to that. So you just say like, hey, is this a thing that exists? And then, you know, does the delegate already exist? Right. So that might be a thing that might be a little bit easier. Here at my cursor, I have a potential alternate syntax. Right. Sorry, I didn't check now. Listen to this event type with the handler in mind. The template parameter clarifies the event type without needing the listener type. It infers from context here in my listener constructor. Yeah. Clear intent less ceremony for this over done. Yeah. I think the implementation should be something along the lines of how are you looking? Still pretty good? Okay. And I think the implementation should be easier as well. This will intrinsically proper add for the given events and pass in the info needed. Because I don't necessarily want to set steps. Because like it'd be really nice if I could just say have a static, you know, have a way to have like an implicitly static something or another, right? But that's also kind of a pain in the ass. Right? So you need to be able to have custom handlers for every single listener. And every listener needs to have a custom handler for every single event that it listens to. There is a bidirectional instability. Because it's many to many, right? However, the issue is that it's many to many at the type, and many to one at the instance, and that makes things very that complicates things quite a bit. So you want to have, hey, this type here has a thing. Right. So there's that. Because, you could say, hey, listen to this thing. So it's kind of right. So I don't know. I'm gonna try it, right? Because it'd be nice to be able to pass in its own type and right, infer the listener type from type of this. You're in the constructor. Get the instance from this. Yeah. Type handle from the lambda. Yeah. Internally call the proper my event.add my listener this handle. One template parameter, everything else implicit from context. The boilerplate disappears and the implementation handles the rest. I want to remove boilerplate. I want people to be able to just sit down and just say, hey, hey, engine, do the thing. Here's some data. Here's the information that you need. Make it happen. Right? That's the kind of ideology that and it's not quite so easy as to just, hand wavy and magic bullshit go. See what sticks. Right? That's just something that is just really impressive and stuff, right? So these are all things that are, nice. Yeah, because there's like a lot of weird bullshit. This can just magically handle everything for you, right? And that would be a lot better. Yeah, listen to my event. Okay, listen. And we could just handle all that right in there. So, how would you suggest we handle the rarity of the as in, how do we enforce the singular nature? It might be, like there could be like a sword. There could be like a sword, something or another. The map enforces it. Yeah, alternatively static tracking in the event itself, compile time or runtime set tracking. Type info theme is simpler and more effective. Oh, you could even have a map of. You could even You could even have a map of the delegates and a array of the instance references. Removing them might be a little bit of a pain in the ass, but yeah. Hey, have the handlers, and then you have a listener array of stuff. Oh, register listener. Yeah, okay. Yeah. Okay. We have that. So you know, dot foo equals. Well, I mean, I guess it'd be yeah, self dot foo event dot bar. Right? Self dot foo equals my event dot bar. That just cleans things up very nicely. So you have the listeners do that stuff. Which makes things super nice. Makes it super nice. That just simplifies the API quite a bit. And simple code is good code. Right. There are very, very rare cases. There are very rare cases in which also simple code is usually rather performant. 9 times out of 10. Some of the most performant code you're going to write is the simplest code you're going to write. Fewer keystrokes or fewer lines usually equals better code. Not always. Right? There are some very, there's plenty of cases where more lines of code is better, but not often, because more lines of code is harder to read, harder to understand. And if you can't understand the code, then it's not good code. Right? Only idiots, think complexity is good. Right? Terry Davis. Rest in peace. He had a lot of problems. Programming was not one of them. That's for sure. Understanding computer science was not one of them. So, but, we can have these things, alright? like the listener could have I mean, the only other way around it is that you have a little bit of indirection, right? You could do a little bit of like an indirection thing where it sets the static, right? It sets the static variable, where the listener has a static variable that listen to my event set to the given delegate if it's not already set, right? So you have a bit of you have something along the lines of class listener. You have static event. Oh wait, but that's not. Oh, as static delegate of alright, of ref listener, right? And then you have listen. Yeah, you have like a void listen to events right. Void listen to event. Here you say like if delegate listener oh wait, but it's only one fucking handler. That's fucking gross. You need one for every single individual. Things. Yeah. Because like it would make more sense that the listener handles all of its shit. But like the whole syntax of hey, here's the thing. Right? The only other way is that you can have like a static list of all the listeners of that type. And then you set the right? But it's also type info and event type info, right? The type info of event. Can you hold it now? Which, might be fine. Because then all that the event needs to do is have a list of all of the different types of listeners that it's listening to. Right? So you could have something like that, but it's actually static delegate type info, right? Handler. Alright, yeah. Type info instance, type info handler. Right. There's no way to, I don't think there's a way to restrict it to of type. To be subtext as as in only of items that are children of listener. Right, is that a thing that you can do? Or, I mean, you can do checks when storing it. If is listen to the listener. Okay. Gotcha. Okay. So you can restrict it. So that, yeah. Okay. Type ID. Maps themselves still store generic type infos, but the constraint guarantees nothing non-listener the constraint needs to be at the setting. Needs to be at the setting of the type info, not storing of the type info. Okay. That's fine. Okay, so yeah, we have that, right? Listen to oh, interesting. T events. If delegate ref listener type info handler. Well, actually, I should name these handlers. Because it's storing, it's effectively storing the events that it's, subscribed to. By type. Because events are stored. Right. Right. So if if handlers or if handlers dot contains type ID of E contains type of ID return or listen to type ID T, I think. Handlers contain type ID T. Yeah. And then it's delegate D. Delegate D. Delegate of type listener D, yeah. Right. Handlers of T equals D. And no matter what, you just say T dot add this. Or T dot bind. Right, T dot bind this. Right? And then it'll just handle everything for you, right? Alright, because here, what we could do is we could say static. Right, here. Events, right? Here we have a static well, it needs to store the types that it has. Right? Because there's and it should be fun, right? No, that's house, not class. This isn't. Did it again. Gee. Freaking dyslexic over here. No, dysgraphia. Let's see. Yes, I know, buzz. Oh, popular today, but it is New Year's. Oh, what am I gonna do? I mean, the event could have a list of info. It could be a type info, something like that. So that in the notify it's just, hey, notify. Panel notify. Right. Because again, I want to limit the boilerplate. The whole point of the abstractions is to remove boilerplate. I don't want boilerplate. Boilerplate is bad. Slows down production. Okay. Alright. Because each of those will have because then it's gonna have for each auto L in listeners, right? L dot handlers ID this something, or maybe instead of handlers it's one dot receive or handle if I do this, right? Question, right? Something like that. And then the handle. That needs to be static. Right? Yeah. Static void listener. That's fine. I mean that actually doesn't need to be done. I can fill handlers. And then we have a static info listeners. Listeners. Because here, what we could do is we could have a static void handle, right? So the static void handle t is events and then here we say for each L, auto L in listeners handlers of events. Oh. Okay. Okay. Yeah, whatever. Don't communicate the listener. But, oh, okay, I'm not. How about you? Yeah, could you as few changes as possible. Change only what is necessary. Because I want to, like, well, I mean, the notify is kind of, let's see. Oh, I kind of need to notify. But that's not Okay. Oh. Okay, yeah. Okay. Handlers have a panel. What is the... Well, I mean, I wanted to check out the, well, I kinda wanted to keep the notify function. It's important for how the system operates. If you put it back in, okay. So let's see. That is the notifier for each. Okay, so does the notify function have any syntax? Okay, at compile time, so let's, okay, so we need to rectify the function. We want to keep bits, but make it actually notify, but already haven't notified my not going to infer it as anything. But hold on. Isn't there a way to clean that up? It's in its own scope, no? But that builds in more boilerplates. I suppose it could be event dot notify my events. Okay. Oh wait, no, I think that, yeah. Got a coordinate. Yeah, Update the doc to reflect. Handled. Fully notified. For each auto L mission. Yeah, so then all that we need to do is just go. The parent events and sending classes to a proposed implementation section. I don't like having it boiled up and a bunch of that, right? I know I'm not supposed to be doing the actual implementation, but the event processing, it's really bugging me. It's not working the way I want. And a lot of these things are like, these are structural problems that I'm up against. And I want to figure them out. I want to see if I can get the desired result, and a lot of it is requiring me to understand what the implementation is, because a lot of this is, implementation dependent, right? Because you can't, directly assert a lot of these things without, these implementations. So I want the overarching events to have this stuff, right? Because what this is going to do is that how much of these things I don't, because a lot of this is also for myself, right? Because the trigger, it's, hey, trigger this thing, and I don't know if I want it to be there's a lot there, right? Because I could have either implementing because I like having the text be trigger other event, trigger event, trigger my event at time 2, at time equals. At time equals this delay, trigger with delay equals, with delay equals now, right? Trigger that event now, right? I like having, because this reads as, hey, we're setting a thing, and it's not like we're not doing anything right now, right? We're not doing a thing in the moment. That's what this is meaning. Here, this is saying we are doing the thing right now, immediately, right? That's how it's supposed to be. That's what it's supposed to be doing. So we need to figure out exactly what triggering an event does. Right? So we need to figure out what this is. Because we want to do trigger. And we could do event.trigger. That is a possibility, but I don't know if I want to do that. And I think having, events dot notify the, event dot notify the listener. Guess we could do event.trigger. Right? We could have event.trigger. Because we're not necessarily going to explicitly call these events, right? Because it could be physics, it could be draw, it could be render, it could be wubba-lubba-dub-dub, right? There's no guarantee that it's going to explicitly state what it is, right? So I think having like an event.trigger, return a trigger type that, or something, right? Because like it would return a thing that we can chain into other things, right? Yeah, trigger returns a trigger type. Right, class, trigger class. Because we're not going to be dealing with trigger classes. Because we're going to be doing a lot of things, either popping it into the scheduler with a thing, but at time, equals a thing with delay equals a thing. That's actually fine. Yeah, that's actually fine because they're properties. Since they are properties, it's fine, right? We're not saying with delay, right? What we're not doing is this. Because if we did this, then that would screw with it. But we're doing this, which means it's fine. Because properties can do that. Doesn't make it can make it a little bit confusing as to the timings, but a lot of it is very declarative. I mean, declaring like, hey, this is what I want it to do. Right? I want it to do a thing. Right? It's very instruction based. It's very intentional, intentive. Intent forward, right? I want people to understand the intent of what the code is supposed to be doing, rather than trying to, just figure it out by the raw, instead of trying to trace functionality, just being able to understand the intent of what is going on. So, like, a lot of these things might be a little bit, it's supposed to just be the intent of things. And then if you really want to, you can just take a look at the definitions and trace all that stuff, if you want to understand how it works. And even doing that should be fairly easy to do, so that people aren't running into as many issues and stuff like that. So we have the listen to my event, we have that. Okay. So let's take a look at event.trigger. Might want to do that, right? Yeah, event.trigger my event. Okay. Hmm. Okay, so we could do... Not even readable. Yeah, no, it's readable. Except it's not updated. What the heck? Oh, I'm gonna be super mad if I'm on line 24. So by the time I do all this stuff, come on. Okay, so I'm on line 24, and it's okay. So it is. Doing what's supposed to. It is doing properly. It's just restream is not updating. It's a little bit concerning. I don't necessarily like that. I'm gonna have to look into that. That's not the greatest. I'm just gonna assume that it's all working. And just deal with it, I guess, or something. I don't know. Guess it will be. I just need to be how it is. I think the event class is something that's gonna be. I could do event.notify other event. Right, event.trigger. 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 Yeah, event.trigger. Okay, do I want event.trigger or do I want trigger? Trigger mod. Trigger other. Trigger the other. Trigger physics. So, or trigger kill player. Well, I should say trigger. Event.trigger player. Yeah. Okay. I think I will. I think I will. think I would want to say, because again, like a lot of this stuff is like a lot of this is, you know, static void trigger key events. What is it? Some kind of delegate, right? A void delegate. A void delegate. A void delegate. Delegate. No, I mean, it's not static void, it's void, it's and then the scheduled trigger is gonna have its own shit. Right. And in essence, all that's going to do is just say, hey, this event that we're doing, right? Because I can like dispatch a lot of this stuff, right? One of the things I can do is say, what is it? The event yeah. The scheduled trigger is doing some stuff. Yeah, it's like a return new schedule trigger. What's the point? And then like the scheduled trigger is going to do because the scheduled trigger is going to have the hook into a notify, not the extra trigger. And the schedule trigger I should say trigger class. Because I don't know. I don't know if the trigger class is going to handle all of that or not. Well, because at this moment, we don't know Yeah, this is a new trigger class. This new trigger class. This, right. Oh wait, but this is actually, okay, it needs to be a new trigger class of type. Okay, I'm guessing, right? Is that the thing we can do? Yeah. Right, and then the scheduler does magic. Because the scheduler itself is where the schedulers are all magic. But for now, what we want is just to have, is we can defer, we can put off a lot of this stuff, right? So we can have the turn new trigger class that has, you know, we just assume that it has these things, right? No, scheduler might have scheduler. Right. Mm-hmm. Yeah, I think we could do like an update or something. An update and draw. Swap, update, draw. Okay, we just declare those as events. Right. And if anything wants to have an update, they subscribe to the physics or whatever. Right? Or I mean, like this could just be an update. Right. Instead of that, it could just be an update. Right. So update might be, I don't know. I'll have to figure that out later. That is out of the scope of this particular exercise. This is just a post-mortem. Figuring out what it is that I liked, what it is that I didn't like. I didn't like using AMP as my IDE. That was pretty painful. By and large, that sucked. It felt dirty. It didn't, and it also just flatly didn't fucking work half the time. In a month, I ended up doing, in 1 month, I ended up doing like 2 days worth of work. It's absolutely abysmal. I started at like 8 o'clock, and I'm already at 12:30. I really haven't been streaming for that long, and I've already done way more work than in the past month, basically. The past 4 or 5 days, the past week, literally the last week, working on the event system, and I've already done way more. Granted, a lot of that was figuring out how I want events to function, and learning a lot of the implications, right? So obviously doing it all over again, it's going to be faster the second time. Because I've already run into the pitfalls. So I already know where all the pitfalls are. I've already filled them in with my own corpse, right? So that is something, to keep in mind, is that of course the second time you do something, it's going to be fast. It's going to be easy. Right? It's like, if you've made Tetris 5 times, the 6th time is going to be the easiest. Because you've already done it 5 times. You already know how to do it. Right? Even if you are used to writing making Tetris in, Godot, switching over to Unity, it's still going to be easier because you've already done it before. Switching from Unity over to Unreal, you've already done it before. You already know what to expect. Even though the whole build system and ecosystem is very different, right? You're still familiar with what it is you're doing. And then going from that all the way into doing it raw in, HTML5. Again, it's going to be a much easier task every single time you do it, regardless of what you change. Right? So do keep that in mind. Like, it's very difficult to assess if doing something a certain way is easier or better when you've already done it a bunch of times. Right? This is the first time that I've made an event system like this. Right? Now it's the second time. So obviously the second time is going to be easier than the first. Because I've already done it. Like, it is the difficulty is only like 1 over n, right? The jump between the first and second is going to be bigger than the jump from the second to the third, and so on and so forth. Right? That's just kind of like a fact of life, right? So there is like diminishing returns over time. The 10,001, the 10,001st time you do it is only barely easier than the 10,000th time, right? At a certain point, like, you stop seeing results, right? Because the change is effectively easy. So do keep that in mind. It's roughly equal to like itself. It's roughly exponential. So what do we have going on here? We would need to update these to be event.trigger. Right. Event.trigger. There's also a lot of like feature creep which I also want to avoid, because there are very, very easy ways of introducing a boatload of features without having a feature creep and obfuscation and complexity. Right? I still want this to be better than not using one. I still want this to be more concise than just not using an engine. Right? I want it to feel that if you try to make a game without an engine, you end up writing all of this anyway, kind of thing. Right? Whereas with, Unreal or Godot, you don't get a lot of that. And a lot of the same thing with like id Software engines. This is very similar to that mentality of making a game without an engine. You effectively just do all this typing anyway, kind of thing. Right, because you're intended to fork to fork all of that. That's really how it works. And that's how I want this to be. It's just a forked, it's a engine that you fork, right? A fork to use. So we have the trigger class, and then we want to have a post implementation of the trigger class, right? And just, instead of like fully chasing, like a lot of this is just instead of fully chasing all this shit, just kind of say like, we'll handle the specifics of dealing with this shit later, right? And just adding more and more specificities later. So yeah, so that way we have like my listener, my listener class, my event class, doing stuff. Listen to my event. So yeah, and this is a really powerful way of doing things. If you're writing an API, sometimes it's better to just write the use case for the API first, right? So that you go, okay, this is what I want it to look like. This is how I want it to feel. How close can I get to it, right? And then you just start implementing towards the usage. Very similar to like, if you're doing something that's very, user interface heavy, you write the user interface first, and you deal with the back end later, kind of thing, right? Because very frequently the forward facing, you want to build from forward to back, from front to back. It's very difficult to do things well if you go back to front, because you end up writing yourself into a corner, right? Like Unreal and Unity have these problems because they're not forward facing, they're not front design. They're back designed, right? They have this idea of this is how games are made. You have a strict hierarchy, and you just populate this hierarchy with the things that you need. If you don't understand it, sucks to suck, right? And that makes writing the front end for that very difficult. Because that means that the user experience, the UX for it, can be very, hard to manage. And a lot of it is because people don't really think of new ways of doing things, right? Everyone's just copying off of id Software, and id Software is like, we know all the enemies that we want, so we could just do a strict a strict hierarchy, right? Things are very static in Doom and in software games in general. There isn't very much variance, and if there is, it's very slight, just one or two things, like a palette swap, and a couple damage things are different, right? So the hierarchy for the the class tree for Doom games is pretty wide, right? They're not very deep. So they're not very deep, and they're very well structured. There's not a huge variance. There's no crossover either, right? An enemy is an enemy. There's not things that act like enemies, so you don't end up having the whole mannequins looking at you when you wake up in Skyrim situation, because you don't have to borrow code from NPCs, right? Because that's how all the code to rare items is all handled by the NPC. So anything that needs to wear our armor needs to be an NPC, because the NPC owns the ability to wear armor. So if you want an armor stand, it needs to be an NPC, and it just inherits a bunch of extra work and extra functionality of NPCs, like locomotion and animation, and right. So that is why you get very weird shit, because it doesn't matter, because it wouldn't make sense to make everything a mannequin and then have NPCs inherit from mannequin, right? In order to have, because then the mannequin would have posable, yada yada, all that shit, because NPCs were probably done first. Would you move all of that code out of the NPC and into mannequin, this new item that you're just implementing, 4.5 months before release? No. You're just going to do it the other way and just deal with the consequences, right? And that's, sure, I didn't work for Bethesda at the time, but I can almost guarantee that is what went down at Bethesda headquarters, right? Because that's what, because that's the kind of shit that happens, right? So that's just the kind of shit that happens when you're dealing with programming. So yeah, I'm kind of going a little bit in both directions, because I'm kind of bouncing back and forth, right? Because the back end is what determines what the front end even can be, right? The back end defines the capabilities of the front-facing API. Arguably, it is what defines the front-facing API. So I need to think about what the front-facing API is. Just say, hey, I'm going to do it this way. This is what I want it to look like. I will figure out how it does that later, right? But you have to figure that out eventually, because that could infer and change what it is. You may be making the front end, you may be, making the front with certain assumptions that when implementing the back disallow, right? You end up getting contradictions that you have to resolve, because it could be either a language restriction or just a fundamental memory problem. A lot of the times, you end up just running into things that are fundamentally impossible. Just not even a different language would be able to do this just fine, right? It's just that there are certain fundamentally different things that just cannot function, right? And changing language isn't gonna, right? There are certain, fundamental contradictions, right? You can't have, like earlier, right? I can't have a statically set data be deferred later without making a function call at that point in time, right? That's not something that you can do. That's a physical impossibility. You can't predict the future, right? So you have to sit down and think, okay, well, do I want to have the, do I want to have a static, a singleton struct, which is not only super messy, and prone to error, but also doesn't, it doesn't change the things. Like I can't have a counter, right? Because I can only have the counter when I'm dispatching them, when I'm declaring to schedule is the only time that I can update the timer, not when it's resolved. Because what if you declare a bunch of timers and one of those timers pulls the rest of, and one of those triggers pulls the rest of the triggers? Well, then now your counter is off. Now your counter is inaccurate. Because you're using stale information, stale data, right? So that means, oh, well, so if that's the case, then I have to have a function call, right? I have to make a function call at some point. So I have to store a delegate that sets the payload on trigger. Again, that's just how that needs to be. And then at that point, just up to the, it's just up to the developer to not be dumb, right? Not be a dumbass. So these are all things that just needs to, yeah. Okay, so that's so cute, right? Okay, so we have all of these. We have let's see here. Okay. So yeah, okay. Well, I mean, we could even make it event too, right? Because then this way it's true class. Yeah. Okay. Yeah. Yeah. I don't. Whatever. I'm just gonna assume that it works. I guess. Because then we have like that, and then it's like a void delegates. New trigger. Yeah, the trigger class is just a thing that, yeah, because the trigger delegate is just a thing that runs when you, yeah. Payload loader. Right. Then we have alright, we have that, and then we have void now stuff, and then we have at property void at time. What fucking long key? And then we have at property void with delay. Long. Okay. So that we can have all that, right? And it's just, you just assume that it does the things that's supposed to. Void now. Oh yeah, we can actually declare. Yeah, we just immediately just do key or events dot notify notify t. Payload loader. Right, we just execute payload loader, and then we do event header. Right? Yeah. Cool. And then the other thing is just do its own. This is something that I think I assume that this is correct. Alright. I've added a few things for you to put over the full documents. I would do that's like the whole. Inside the event. Oh, okay. What? I'm 40. I'm not in the event class, you fucking dumb fuck. So down. Okay, down. You've made some incorrect assumptions. And just take another look. Just take another look and try again. Don't necessarily want to, just take another look and try again. Or just skip. Don't assume they're broken, just incomplete. Yeah. Correct. You don't bind that this is just a line through one. Yeah, no, I need to fix line 90. Yeah. Okay. No, actually, I think that's probably right. Yeah, line 71. Let's take a look at line 71. Yeah, P dot bind. Event. Yeah, event doesn't have a bind. Probably it would be good to have a bind. Let's see. Bind. Listener. Listener L. Alright, well, I mean, I guess I could just say fucking an unordered set. Or, yeah, I mean, I guess if you do unordered set of type info, right? Or am I already handling it properly? Don't find this. Void listen to if feelings and handlers. Oh wait, no, it's not. Alright. Undo. How do I undo? I don't know how to undo. how do I undo and mail them? Because full you normal mode. Okay. Info this one. Right. Okay. I mean, I might not necessarily want that, because I could just say, I mean, it's a bunch of indirections, but whatever. Like, also, do keep in mind that compilers are very smart. They are smarter than you. Okay. They're going to compile a lot of your bad code away. To a point. Okay. To a point. But, by and large, you're not going to write better code than them. Just write code however you want, and the compiler is going to largely optimize a lot of that bullcrap away. Right, as long as you're not making fundamentally flawed ideas, it's fine. Okay, like that's just how it works, right? So like static bind, like do we want to have a t.bind, right? Do we want to bind to this? Because what we want to do is we want to say, hey, here's a thing, add type of, right? Like do we want to have do we have it? Oh, do we not have a typo? Yeah, because this is the example, right? Well, I mean also, yeah, let's say, dispatch to scheduler, dispatch to one second. Alright, I'm actually gonna end it here. Something just came up that I have to take care of. I will be streaming again tomorrow. Also testing out to see if this actually uploads to YouTube properly and all that stuff. So yeah, I will see you guys later. Bye.